when we have an equation where the variable is squared, the shape that we get when we graph it is known as a parabola, and it's this, oh, I need a pen. It's sort of U-shaped like this. And one of its properties is that it's symmetrical around a line that goes down through its center. Let me undo that now. Okay, now let's take a look at our quadratic formula. It really has two parts. First, there's this part right here, which is known as the determinant. It tells us how many solutions we're going to get. If the determinant, what's inside of the square root, is 0, the square root goes away, which takes away this plus or minus. And we have only one solution. If it's positive, then we have two solutions because of that plus or minus. And if it's negative, there is no solution because there's no such thing as a square root of a negative number, at least not in the real numbers. So, if we take the determinant away, what is left? X equals negative b over 2a. This is the equation of the line of symmetry of that parabola. So we can plug in the numbers from the equation to find out what the equation of our line of symmetry is. Let's do that. And of course the vertex of the parabola, the maximum or minimum point, lies on that line of symmetry. So let's go ahead and plug it in. X equals negative b. G. B is the coefficient of the term with the variable that's not squared, and we don't have one. So that means that our b, in this case, is 0. And then over 2 times a is 2. So now we have x equals negative 0 over 4, which of course just equals 0. So the equation of our line of symmetry is x equals 0. Now, as I mentioned, our vertex lies on this line of symmetry. We need to plug this 0 in for x into the original equation to be able to solve. So now we have, and let's change colors, y equals 2, and then we'll plug in a 0 for x squared. Well, 0 squared is still 0, and 0 times 2 is 0, so y also equals 0. And this gives us what they want in the box. What is our vertex? In this case, our vertex is the point 0, 0, because x equals 0 and y also equals 0. Now, in order to be able to graph this, we need to find some more points. Oh, and before I go too far, we're going to make a t-chart to keep track of these. So here's my x, and here's my y coordinate. So the first point we found, and I'm going to put it down here in the middle, because it's the vertex, it's the line of symmetry, it really belongs in the middle. The first point we found is 0, 0. We're then going to find some points on either side of that. Okay. So now that we have that, we need to go back to, and let me just rewrite the original equation here. The original equation was y equals 2x squared. So I'm going to write y equals 2x squared. Okay, now we need to find a y-intercept and an x-intercept. In this case, we've already done that because When x equals 0, which is how we find the y-intercept, y equals 0. When y equals 0, which is how we find the x-intercept, x equals 0. So my x and y-intercepts both fall at 0, 0. Now I need to find some more points. So let's go over to this page and put in our equation again. Y equals 2x squared. And let's try plugging in some values. Well, I want some that are greater than 0 and some that are less than 0 for my x, so that I can figure out what y equals for that. So let's plug in. Let's try a 1 for x. So we'll plug in a 1. And what does that give us? Well, 1 squared is 1. 1 times 2 is 2. So y equals 2. Okay, let's try a negative number. Let's do negative 1. So now we've got y equals 2 times negative 1 squared. Okay? And negative 1 squared is positive 1. Positive 1 times 2 equals 2. So y equals 2. Okay? Let's go back to the positive side and try 2. So now we have y equals 2 times 2 squared. 2 squared is 4, and 4 times 2 is 8. So y equals 8. Let me move that down so I can write on it. Y equals 8. Okay. Let's try negative 2. So y equals 2 times negative 2 squared. Well, negative 2 squared is 4, and 4 times 2 is 8. So y equals 8. And now I can go ahead and take these points and make my graph. But first let me point out something here. This is that symmetry we were talking about. 1 and negative 1, which are equal distance either side of the vertex, both give us, well, equal distance either side of the line of symmetry. They both give us the same answer, too. Same thing with 2 and negative 2. They both give us 8. Let's see what this looks like. And like I said, the important part is that those are equal distance either side of the line of symmetry. The line of symmetry may not be y equals 0. In this case it is. Or, I'm sorry, x equals 0. In this case it is. So let's see what this looks like. We have a point here at 0, 0. And then we go over to 1. And we have a point at 1. And we go over to negative 1. And we have a point at 1. And then we go over to 2, and we have a point at 8. And at negative 2, we also have a point at 8. Let's try some more points and see what this looks like. Let's go ahead and plug in 3 and see what that looks like. So now we have y equals 2 times 3 squared. Well, 3 squared is 9, and 9 times 2 is 18. So y equals 18. Now we'll do the same with -3. So y equals 2 times -3 squared. When we square -3, we get 9. And 9 times 2 is also 18. So y equals 18. So here for -3, we also get an 18. Again, continuing the same symmetry I was talking about, let's put those points in. So now if we come over to 3, and we're going to go up to 18. Same thing at -3, we will also be at 18. And when we graph this, and really a sketch is all we're looking for here, we're going to get, and I'm not a very good artist, so bear with me as I miss the points. We're going to get something sort of U-shaped, and I missed that point pretty well, but we're going to get something sort of U-shaped. I didn't draw it very well, but you get the idea. Your book, your packet actually shows this graph, and they do a much better job of drawing it than I do.